Today, I will be talking about two name reactions. The first reaction I will be talking about is the Stetter reaction, and the second is the benzoin. The Stetter reaction involves catalytic sodium cyanides, or more commonly, thiazolium salts. It is also most similar to a Michael addition, which you have previously learned in organic chemistry, and it makes gamma oxonitriles or gamma diketones. Here, I've shown an example from the textbook. This is combining an aromatic aldehyde with an alpha-beta unsaturated ketone using the sodium cyanide to make a gamma diketone. Here I've highlighted a new bond forming between carbons in black, and I've also labeled your alpha-beta gamma carbons to highlight the gamma diketone that is formed. Now I will be walking us through a generic Stetter mechanism. For ease of following, I have color-coded the mechanism for us, and all arrows indicating movement of electrons are in black. First, we are going to take this lone pair located on this carbon and attack the beta carbon included in this alpha-beta double bond. This will make the double bond move over, forcing these electrons up onto the oxygen, forming an enolate. From there, we will do a proton transfer, which I have abbreviated as PT, and you will see this later as well, to take the lone pair now on the oxygen and attack this hydrogen, pushing the electrons onto this oxygen on the left, which forms an enol. From there, the electrons now on the oxygen on the left will move back down to push off the cyanide. Lastly, there is another proton transfer, this time between the double bond and the hydrogen that we added to this oxygen from the last proton transfer. In this final step, we have now created our gamma diketone. The next reaction I will be discussing is the benzoin reaction. This reaction involves aromatic aldehydes or alpha-ketoaldehydes, and with the previous Stetter reaction, cyanides or more commonly thiazolium. This reaction is most similar to an aldol reaction also learned previously in organic chemistry. Here below I have included an example from the textbook, and this reaction will be using the sodium cyanide. As you can see, there's a new bond formed to where this previous carbonyl was, and now you have an OH there. I will now walk you through a generic benzoin mechanism. First, you start with your negatively charged cyanide, attacking this carbonyl center, moving the electrons up onto the oxygen. This creates a charge on the oxygen, which then does a proton transfer to get this proton from the center carbon. Now the lone pair on the center carbon can add to the center of the other reagent, pushing those electrons up onto the oxygen. Next, another proton transfer happens between the oxygen with the lone pair and the oxygen on the original material. Once the proton transfer happens, this oxygen contains a negative charge in which a lone pair of electrons can then move down to kick off the cyanide as seen here. Lastly, we are left with our final product. I will now be putting a literature example up on the screen for you to guess that reaction. If you get stuck, remember that a Stetter reaction is most similar to a Michael, and a benzoin reaction is most similar to an aldol. I'll give you a few seconds to guess. If you guessed that is a benzoin reaction, you would be correct.